Welcome to REDARC Electronics. I'm Ben Marsh, Sales and Marketing Manager. Here at our Lonsdale facility, we have over 200 people on site that are researching, designing and manufacturing products primarily for the automotive industry. We make products such as voltage converters, DC power supplies, in-vehicle battery chargers and electronic brake controllers. Our products are used in the RV, trucking, 4x4, defence and industrial markets and sold all over the globe with major export markets in North America and Europe. We originally built on this site in 2007 and have undertaken 2 major expansions since. The most recent expansion we finished in late 2018. With this expansion we invested in state-of-the-art manufacturing and testing equipment that allows us to be a proud Australian manufacturer that is at the cutting edge of technology well into the future. So let's take a look inside.
Hi, my name's Dr. David Murfitt and I'm the Engineering Manager here at the REDARC Research and Development Innovation Centre. We have a range of engineers and technicians who develop our products. They include people who have electronic hardware design experience, working on the printed circuit board and the electronics hardware. We have embedded firmware designers that are writing the code that go into the product, and mechanical design engineers as well, who are then doing both the industrial and mechanical design surrounding our products. The team here is the ones who are responsible for creating the devices that then are manufactured in the factory on site. They include a range of different skills and experiences, and the products are interconnected into the internet via apps on mobile phones, via Internet of Things, through GSM, through GPS, and that gives us the ability to collect data about how our products are used and interact with our users in a better way.
Hello, my name's Brad and I'm a manufacturing engineer here at REDARC Electronics. Welcome to the Manufacturing Engineering Workshop. Beside me here are our 2 3D printers, our Creatality Pro 3D printers. We use these for prototyping parts to make jigs and fixtures. We've currently got, I think, around 35 to 40 jigs and fixtures in production that we use for testing all of our equipment, holding things for our operators, anything we can do to make things easier for them. Back to the prototyping, we make a lot of parts and components in-house from scratch using our computer-assisted design, our CAD software. If we want to prototype and print these parts, we use our printers here. It saves us from sending these out to be done by machinists externally, which can take a lot longer to come back, cost a lot more money. We also use our printers to run through a range of production parts. These production parts are usually only quite small, and we make sure we cover them with some kind of potting or silicone, because at the end of the day it is just a plastic. These printers really help with our efficiency and productivity, especially when, as I mentioned before, we just can't afford to send parts and components out to get machined externally. If we do need to get a really fine print and a really nice exterior finish, we can get some bigger companies to print parts for us, which use slightly stronger materials, and they can get quite a nice finish there, but usually these printers do pretty much everything we need them to do.
Hi, welcome to REDARC Surface Mount Technology Room. My name's Lorianne. In this room we have a staff team of 23 operators, technicians and engineers. 7 of them are currently studying at Tafen University. Our environment is an ISO Class 8 clean room, which means we have to monitor the temperature, the humidity, the air pressure, and we even do an airborne particle count to ensure that our environment is up to standard. We have 2 surface mount lines. Combined, they place in excess of 5 million components a month onto our circuit boards. Our new line offers traceability down to component level using technology such as a laser marking machine, which etches a unique ID onto every circuit board. We also have a dual head pick and place machine. This has the capabilities of placing up to 50,000 components per hour. We also have a dual lane vapor phase reflow oven. Now this is cutting edge technology, and this was the first machine installed in the Southern Hemisphere. It's fitted with a vacuum hood which displaces oxygen and allows for a better solder joint. At the end of the line we have a 3D automated optical inspection machine. Now this inspection machine is going to inspect the solder joints and the components to ensure the quality of our surface mount lines. We also have an X-ray machine which allows us to see the internal conditions of components and the solder joints. Other processes we do in this room are selective through-hole, PCB washing and automated circuit routing. Once our circuits are routed out into individual circuits, we pack them into boxes and we put them into the production area where they're going to fit further wiring, wire looms, casings, packaging, and finally export.
Hi, my name's Jake Brackenridge. I'm the Assembly Manager here at REDARC, and welcome to our production facility. The next generation of manufacturing for REDARC will be stepping into the automation field using collaborative robots. These collaborative robots will be used for the automated assembly and test of our electric brake controller, the TowPro, which is one of our highest volume products. You'll see we've used 3D printed parts in a majority of places throughout the cell, and we're using highly complex 3D vision and 2D vision systems to help the locating and picking and placing of parts during the assembly process.
Welcome to the EMC lab at REDARC Electronics in Lonsdale. The EMC lab is like a shielded room that is basically a pocket of air devoid of electromagnetic noise, but also radio stations, Bluetooth, Wi-Fi in the building, whatnot. This area is completely quiet in that sense. Well, not completely. In engineering, nothing is 100%. It's 100 dBs quiet. So what we do here is we test our products for EMC. EMC, electromagnetic compatibility, is the branch in engineering that deals with the operability between electronic devices and the unintentional radiation that these devices do. Every modern device nowadays that holds a microcontroller will generate some noise. There is always a footprint of EMC, whether you like it or not. And the challenge of manufacturers is to keep that under certain limits as prescribed by the standards of the market that you intend to operate in. So there's two sides to this coin. On one hand, there is the emissions, but on the other hand, there's also the susceptibility of the product to electromagnetic noise. So we do two things. We measure the unintentional emissions, but we also bombard our product with intentional high-level, high-severity RF noise to see how it behaves. And this is especially important for safety-critical devices. For instance, this device that we have right now is a brake controller. A brake controller is a safety-critical device. If you are driving near a radio tower, it has to work. It's not acceptable if the brake controller stops working if you're near a radio mast. So we test both emissions and immunity. Why did REDARC invest in such an expensive kit of equipment? It's two reasons. One of them is time to market. Imagine if you're, as a design engineer, you're at the end of your design, you think you're ready, it's all working, all good, sales is ready to sell it. As an engineer, you have to put your hand up because you know regulation, and you need to tell everybody in the company that it still needs to be shipped out to a test house for EMC testing, running the risk of failing. And if you fail, you would have to go back to the drawing board and change your design, tweak your design, if you will, without being able to measure, which is not easy. If you can't measure what you've tweaked, there's no way of telling that you're going to pass next time. So the engineer, historically, generally, an engineer wouldn't like to be in that painful position again. So he'll make sure that next time he'll he'll pass, and he'll do that by adding as many components as he can to make sure that he stays under the limit, resulting in an inefficient device. Inefficient in the sense that it will run hot. Like if you have battery chargers that normally run at 60 degrees, if you create an inefficient one, it'll get a lot hotter, which has all sorts of nasty side effects, obviously. So that's what we do here. A shielded room is a metallic room. It keeps all the noise out. However, because these are antenna measurements and the device on the test emits out in all directions, you don't want some of the radiation to bounce off the walls and end up in the antenna because it would disrupt your measurement. So that's why we have these absorbers on the walls. There's two types of absorbers. The soft and squishy ones, the blue ones there, and also the grey ferrite tiles higher up, all done up by hand. It was a big job. They both do the same thing, but they do it in different parts of the spectrum. So the ferrite tiles, they work up to 1 gigahertz, and the soft and squishy foam absorbers, they work from roughly 1 gigahertz up to 26 gigahertz. So that covers the spectrum that we're interested in generally.
Okay, welcome to REDARC's Vibration Laboratory. So just behind me here is our HALT chamber. So that stands for Highly Accelerated Life Cycle Testing. And for us at REDARC, this is essentially for our design engineers like a window into the future. So the combination of extreme vibration up to 75 G RMS on the table, and extreme temperature swings from minus 100 degrees up to plus 200 with a ramp rate of about 100 degrees a minute using liquid nitrogen as the cooling medium, gives us a really extreme combination of thermal shock and vibration, and things on our product will fail. It's essentially about understanding the operating and destruct limits, and our design engineers will be able to have a look at that and work out whether there's what can be done iteratively through the design process from early prototypes to come up with a very robust product for our customers. So over here is our agree chamber. So this really is like it's a pass-fail test that our customers will expect us to pass. Random vibration, sinusoidal vibration. It's a single-axis electromagnetic shaker coupled with an environmental chamber, and we can basically provide vibration testing to customer specifications, military, automotive, OEMs and the like, and simulating real-life transport vibration, rough track on the road, shock, etc. So the combination of these two vibration apparatus at REDARC gives us a really solid way to basically produce very reliable parts for our customers.
Hi, my name's Jo Hugman. I'm the Industry 4.0 Project Manager here at REDARC. Welcome to the dispatch area. So this is the important part of our process for our customers. It's where our finished goods are packed and sent via the couriers to the customers. So all of our Industry 4.0 information systems and technologies really help all the different teams work together to support this team to be able to deliver to our customers on time. So for example, the sales team take the order from the customers and enter it into our enterprise resource planning system. If the parts are available at that time, they're reserved in that system and a pick list is created for the dispatch team to fulfill. If the parts are not available at that point, then an order is sent to production. The production planners review all the production orders and run the simulations in the enterprise resource planning tool, and they decide which jobs to run on which day through production to ensure the customer orders can be fulfilled on time. Once all the parts are ready, the pick list is created by reserving those parts for that customer, and the dispatch team receive it immediately on their screens, and then they can pick the order, pack it, and interact with the courier systems to send the products off to that customer. So what Industry 4 does for us, in addition to helping us all work together in a more efficient way, is it means people can see what's happening throughout the business in real time. So everyone can see where the orders are at and what's due. And we also have summarised information which shows the managers how well the day is progressing and whether or not they need to intervene or to take other action. So thank you very much for coming on our tour of REDARC.